Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share our video and also subscribe. If you have not subscribed before, kindly press your subscribe button for of direct updates from us. And presently we have over 300 videos on our platform. It means you can come here and learn any topic of your choice: mathematics, physics, chemistry. And if you need any help from us, like you need our online class, you want to meet us one-on-one, we have physical class, we have online class, you can contact us with this number. You can contact us with the help of this number. You can contact us, you can call us, you can also WhatsApp, and Telegram is also allowed. Either of the three, you are good to go. And physical class also, you can also drop comment. You can also comment below. No problem. On this video, I'll be walking you through problems on waves. Problems on waves. We all know what is called waves. We have wave part 1, which is a wave definition of waves. Please make sure you watch the video on waves before you watch this one, because I've explained everything you need to understand on wave in the previous video, which is amplitude, periods. We have done a lot of things. I'm talking about amplitude, period, talking about speed of a wave, and so on and so frequency, and so on and so forth. But this time around, I will just be walking you on problems. When you have exam, or you meet any question on exam hall, how will you go about it? For instance, look at this question. I have this type of problem here. Okay, which we have done this in our previous video. Please try to watch that to really be of help to you. I have this type of wave. Okay, let me create this one. Now, I now have another one like this. This one is called Y. Now, I now have another one which is goes like this, and comes like this. We call this one Y. Now, let me quickly make an illustration. The diagram above shows two wave forms, X and Y. Shows two waveforms, X and Y. If the frequency of X is 30 Hz, what is the frequency of Y? We have options. We have A, we have 12 Hz. B, we have 19 Hz. And C, we have 60 Hz. And D, we have 75 Hz. Now, how can we solve this type of problem? It's a very simple one. And anytime you meet something like this, how will you go about it? Let me call it solution. I'll manage this part of the board because we're wave. Sorry about that. Now, one thing I want you to know is that when we talk about the wave frequency, which is my wave frequency, which is I've explained that in our previous video. My wave frequency, which is my F, it will be equals to number of lambda divided by what? Time taken. That is frequency for you. Now, and if I'm talking about that, it means I'm talking about how many lambda are we having x as one wavelength, because which is one wavelength. Okay, my x has a one wavelength, and frequency is 30 Hz, which is that's that, and the frequency is 830 Hz. Now, what can I do now? I think from here. Now, okay, now what we are talking about now is that I will now say that what time taking by x is number of x divided by frequency, which is equals to 1 all over what 30 seconds. It means on one wavelength, which is going to be 1 divided by that, which I will have it in terms of that. Now, from the diagram, which is y as okay, no, sorry, this is y, this is x, sorry. Okay, this is from the diagram. Y has how many? We have one, 2. From here to here is 1. From here to here is another 2. Sorry. Now, it has, yes. It has, which is going to be what? 2.5 lambda. 2.5 lambda, that's what Y has. Y has 2.5, Y, from diagram, Y has 2.5 lambda. That is my Y for you. Now, since I have that on Y, it means also takes 1 all over 30 seconds. 1 all over 30 seconds. 1 all over 30 seconds. And what next now, which is seconds, the same as what? Same as x. Now, since I know that, I can answer that what? Frequency of y will be equals to number of lambda divided by time taken. Which I'll be having, what is number of lambda? 2.5 divided by what is our time taken, which is going to be 1 all over 30 seconds. Now, by so doing that, I will be having, permit me to rub the question, because I have to, one part of the question. Okay, let me rub this side of the question. Now, from that, I can now say that which is going to be 2.5 divided by 1 all over 30, which is also implies 2.5 multiplied by 30, which is to be equals to 75 Hz. That is my answer. It means my answer is D of that place. Now, D of that option, which is option number D. That's the solution for that one. In our previous video, I've explained how to generate wavelength from your diagram, which is, make sure you watch that. Very, very important. Now, another question can come this way. Okay, now, another question can come this way. This is a problem from WAEC. Now I have this. This one must end somewhere. Please stop that. Sorry for my dad, for my mate of the drawing. I'm sorry about that. 1, 2, 3, 4, 5. It's correct. 1, 2, 3, 4, 5. Now the diagram above shows a wave form in which energy is transferred from X to Y in a time of 2.510 raised to power minus 3 seconds. What is the frequency of the wave? Now, solution to this problem. Let's try to work on this. Now, the first thing I want you to know here is that we'll be talking about the number of waves. It's very, very important because of number of waves is already on your diagram. And I've told you in our previous video how to generate number of waves. Now, number of waves, number of wavelengths. If you don't understand that, make sure you understand that from our previous video. How do I do from here? 1, this is 1, this is 2, this is, sorry, the diagram is not very proper, but this is 2.5. With what I'm seeing here, 2 whole number, 1 all over 2, or 2.5. Anyhow you call it, we call it, can put a lambda in it, shows that it's a what? It's a wavelength. Now, my frequency, it will be equals to number of wave length divided by time taken. Now, what's our number of wavelength? 2.5 divided by what's our time taken? I have 2.5 multiplied by 10 raised to power minus 3 in seconds. This will cancel this, which as far as multiplication, it means my frequency will be equals to 1 divide 1 multiplied by 10 raised to power minus 3, which it also implies 1 multiplied by 10 raised to power 3 in Hz. That is my answer. You can see it's very, very simple. But the technicality on this part of physics is ability to know your wavelength. Once you know your wavelength, everything you need to do with the definition I've given in our previous video, I think you will understand everything so far. Now, let me show more examples if time permits me. Okay, I think I still have some time to play with. Now, look at this question. A wave travels a distance of 20 centimeter, 30 seconds. The diagram, the distance between successive crests of the wave is 4 centimeter. What is the frequency what is the frequency of the wave? Now, what I need to do is that this is very simple anyway. Now, I'm looking for the what? The what solution to this problem? Let me write out my parameters. The first thing I will notice there, I have my what? My lambda, which is known as my wavelength, is what? Is 4 centimeter. That's my wavelength. And the distance wave, it will be 20 centimeter. What else do we need to? And the time, which is going to be what? 3 seconds. Now, it means we are looking for the what? What is the frequency of the wave? Now, the frequency of the wave is what I'm looking for. Now, I can say that what? My wave speed equals to, which I've explained that in the previous video, wave distance divided by time taken, which I have it in terms of what is our wave distance? We have 20 divided by time taken, which is 3. I have it as 3. Now, which I will have it in it will be 6.6. It will be 6.6. Yes, 6.6. Now, since I know that, I will now say that what my wave, which is my velocity, equals to of lambda. Now, which I will have it as my frequency will be equals to this, which is wave speed. This is wave speed. My wave speed all over what? All over wavelength. All over wavelength. Now, what is my wave speed? Which implies we have 6.6 divided by 4, which is my wavelength is 4, which is my lambda. Since I have that, it will be equals to which is implies calculator 1.67 Hz. It means my frequency, it will be equals to 1.67 Hz. That is my frequency. That is my frequency. Can you see all these things are very, very simple? It's very, very simple. Just be able to understand what you need to understand at the beginning means you are good to go. Let me show another this thing on this. Okay, let me try to understand a question. Okay, a wavelength of ultraviolet radiation is 400 mn if the speed is light. If the light in air is 3 multiplied by 10 raised to the power 8 meters per second, then the frequency of the ultraviolet radiation is on question. I have A as 1.3 multiplied by 10 raised to the power 15 Hz. B, I have 7.5 multiplied by 10 raised to the power 5 Hz. And C, I have 1.2 10 raised to the power 11 Hz. And the last part, which is going to be D, is 7.5 10 raised to the power 14 Hz. Now, let's try to work this question out together. Now, when you have something like this, the only problem there is that ultraviolet radiation, which we shall know that if it's not, we call it is 400. It means the wavelength also the same thing as what? Ultraviolet radiation, it means my wavelength will be equal to 400 nm. Now, which can also be equal to 400 multiplied by 10 raised to the power minus 9 meter, which is I've just tried to convert now. And also I have my speed, which is also known as what? Velocity of the wave, which is equals to 3 multiplied by 10 raised to the power what? Power 8. Now, since I know that, and we know that our value equals to what? Frequency and wavelength. And I'm looking for what? My frequency will be equals to all over what? Wavelength, which I'll be having, yes, which I'll be having that. It means my wavelength is equals to, which implies 3 multiplied by 10 raised to power 8 divided by, I have 10 raised to power 9, I have 400 raised to power 9. Yes, I have 400, which is my, yes, 400 power minus 9, which once I do that, I will have it, yes, okay, that is going to be, that's just it. Now, by so doing that, I will do my little of calculation. Whatever I have here, it will be HZ. Now, it will be, normally it will be 10, this is going to be 10, 3 raised to power minus power 8 divided by, we have 2 here, 2, it will be 4 multiplied by 10 raised to power 2 multiplied by 10 raised to power minus 9. I think I'm just working on the mathematical part of this, which it will be 8 take away 2, which is going to be 6. It means what? 3 all over 4, 10 raised to power minus, we have power 6 plus 9. This one and this one, I don't really tell you together anyway. For your information, this minus this, which is indices, what I'm trying to play with. It means this divided by this, it will be 7.5. That's true. Yes, it will be 7.5. 7.5 10 raised to power 1 to, which will be 9, 10, 15. It will be 10 raised to power. Is it 15 or 14? It will be 10 raised to power 14. 9, 6. This and this, it will be 7. It will be 15. 10 raised to power 15. Yes. Oh, wow. Okay. Okay, 10 raised to power 14. It will be 10 raised to power 14. Sorry about that. 10 raised to power 14. That is my answer. HZ. That is my final answer. Okay. I think from here you can see that it's very simple to relate with what? Wavelength and other things so far. Okay, for the last example on this part, before I call it a day. Now, look at this question. I have a wavelength this way. Sorry for me, I cannot draw very well. I'm sorry about that. Now, this is going to be what? At this point, we call it 0.05. This is 0.10. And this is 0.15. And this is 0.20. Now, what I need to have here is that the diagram, these are Y question, please, above represent the distance, displacement. Now, of time graph of a progressive wave choose the frequency of the wave Now look at this question. Now what I need to do now is that the first thing I will need to do, okay, I will have my wavelength solution to this problem. From what is given, my wavelength, which is my wavelength, it will be let me draw another one on this part, which is, let me add another one to this now, that would to be very accurate. This is going to be 2.25. Now my wavelength will be in, these are seconds, which is going to be, it's measuring time. It means everything there, it will be time. It means my wavelength it equals 0.25 seconds. Now the next thing I need to do now is that I need to work on my lambda, number of lambda, which is going to be 1, 2, and 2.5. It means number of what? Lambda, it will be 2.5. And what else? Time taking. What time does it take them? Which means my time also is time taking. It will be equals to 2.5 also. Now it means I can say my frequency equals to number of wave length divided by time taken, which I have it in 2.5 divided by 0.25, which I will be having it in terms of 10 Hz. 10 Hz. That is just what I will do for that. That is all. That is all you need to know. Now I will be stopping here. Don't forget you are home with Further Solutions Academy. Further Solutions Academy. Kindly encourage us, just help us to share our video anywhere you see it. We have a lot of videos for you to watch, to play with, and make sure you subscribe, share, and and subscribe if you have not subscribed before, so that you can get direct updates from us. And anytime you want to need us, our class, you can reach us with this line. Which you can do 3 things with this. You can call us, you can WhatsApp us, and Telegram is allowed. Once again, thanks for watching.